Dear ladies and gentlemen, welcome to our first ERCI webinar in this year. It's on additive manufacturing technologies, and as already done by the end of last year, this webinar is in cooperation with the EU project STARS. My name is Lutz Hübner from the Cluster Transport, Mobility and Logistics in Berlin and Brandenburg, and we are a member of the European Railway Clusters Initiative since many years, and now also officially in this new legal entity. The ERCI has been founded in 2010, and since last year, it's became a legal entity based in Brussels. It covers 15 railway clusters from 16 European countries. How does this happen? There is one cluster which is responsible for more countries than only one. It's from former Yugoslavia. The West Balkan states are also part of our territorial coverage, as you can see from this map. We are in charge of about 2,000 companies in total, of which the majority are small, medium-sized enterprises, and we have also good contacts to the research community, to several networks as mobility goes additive, for instance, and also to incubators and accelerators. Yeah, what are our services? The services are mainly to support small, medium-sized enterprises in getting international, in find new market opportunities outside the own country, to find a good network between enterprises and research. To improve the visibility on European level, and for instance, with partner matchmaking in research and development projects, for instance, for Europe's Rail and for Horizon Europe. Our highlight in the year are the annual ERCI Innovation Awards, and every of these 15 clusters have the possibility at least to nominate maximum three applications for this competition. And in this year, we will have a ceremony during the Traco Fair in Gdansk end of September this year. And yeah, what we are doing, we are dealing with innovation topics, for instance, cybersecurity, multimodal logistic, green and sustainable mobility, norming and standardization. In the future, also the very important topic of human factors, due to some task forces we have been established. The cybersecurity task force was the first one established in 2017. Yeah. Also, we give enterprises the chance to introduce their innovative solutions due to webinars, due to bilateral visits, and other possibilities in the future for sure. Also, we think about to have conferences, to have joint booths at trade fair shows, and so on. You can find some information on ERCI on our webpage, on Twitter and on LinkedIn. And next slide, some words about the STARS project. It is to support European small, medium-sized enterprises in successfully adopting advanced technologies to boost product services, manufacturing processes, and the organization. And the first question of this project is how digital mature are European SMEs in order to apply advanced technologies in their processes. And you are still invited, if you are in small, medium-sized enterprise, to answer our survey in order to get an idea what your demands regard to adopt advanced technologies are. And as soon as you've answered this questionnaire, we will contact you and offer you some support. The general question is to answer innovation trends of the railway sector until 2030 to tackle these innovation trends with the help of advanced technologies by small, medium-sized enterprises. And some keywords you are find in this cloud, what advanced technologies mean. What we are offering is first, there are some cluster organizations being a partner of the STARS project. They have for sure their own networks and are able to find some connections, some international connections to the other networks to interest the small, medium-sized enterprises to getting support from the STARS project. Then on the second level, we are able to give some business support and some technical support with the help of strategic alliances, international ones. They are led by each of one technology center, which is part of the project. And the one strategic alliance consists of about 10 small, medium-sized enterprises with nearly the same demand and from at minimum 3 European regions. The third element of these SaaS projects are the hack and match events, where the more traditional small, medium-sized enterprises will come to contact to the more tech-savvy scene, to the startup scene, to tech-savvy institutions, enterprises, which could bring all their knowledge on advanced technologies in order to define, for instance, use cases for traditional small, medium-sized enterprises to be applied in the future. And the hack and match event, the second one, in total, there are 5. It's on the big topic, big data for railway processes, products, and services. And for the moment, we are in the phase of a call for solutions. It is ongoing until the 23rd of January. That means challenges are already on the table. Tech-savvy institutions are able to apply in the call for solutions in order to take part in this hack and match event. The launch event will be on the 25th of January. The teamwork part will be on the 26th and 27th of January, and the closure meeting will be in the later afternoon of the 27th of January, and some time in February will be an awarding ceremony of the most interesting solutions elaborated during this hack and match event. And hack and match does not mean only hackathon, but also matchmaking. And therefore, we have also a B2B matchmaking platform, which could be used to get in contact to each other, to present products, services, solutions, and ask for them. It is open. We have about 50 participants so far. For sure, it could be more. Registration is quite easy. And for sure, it's free of charge. And we have some dedicated dates defined for matchmaking. In generally, you could do matchmaking every time, but on the 9th and 20th of January, that means tomorrow and on Friday, you are able to ask for availability with two participants which you are interested in to get in contact with. Yeah, why you should participate in STARS Hack and Match? You are, for instance, a tradition-oriented SME, and you wish to operate. You operate in the railway and multimodality sector. Are interesting. Or you are interested in adopting advanced technologies. Maybe you are tech-savvy SMEs. And which could provide solutions, and also academia, research centers, large industries, other stakeholders are invited to take part. There are some benefits in taking part in Hack and Match. For instance, publish, showcase your products, project services, initiate and arrange one-to-one meetings, generate fresh leads and meet new contacts, and stay one step ahead of your competitors. Yeah, top 5 objectives to make your participants a success. You can meet partners and customers. You could discover new products and services, prepare purchases or project, meet new suppliers, and get information about latest trends. So that is the STARS project, and you are warmly invited to be a part of it. And it's already 10 minutes left, so we should start with this first presentation. And additive manufacturing is one of the advanced technologies addressed by the STARS project. And so we invited some experts to give us an overview on this technology and the possibility to benefit from a good network. And the first presenter is Stefanie Brickweger. She is the managing director of the Mobility and Medical Both Additive Network. And she is also responsible for additive manufacturing topic at Deutsche Bahn. And she will present the 3D print your warehouse. And we are very excited to hear your presentation. The floor is yours.
Thank you so much, Lutz. And so let me share my presentation. I'm really happy to be with you today because I think the potential of 3D printing in the railway sector is enormous. And I can say so because at Deutsche Bahn, we initiated our corporate project 7 years ago, and you will learn later how many parts we've already printed. If you take a closer look at additive manufacturing, which is the expert expression for 3D printing, then you will find out that by the year 2040, experts say that 50% of all parts worldwide will be printable. Anything you can think of, 50% of that will be printable. And already today, we have more than 50 different technologies in additive manufacturing. So this is not just the 3D printing technology, there are enormous amounts. If you want to know which sectors already use additive manufacturing, you will find out that very soon, about 30 years ago, when this technology was established, the aviation industry started with additive manufacturing. Because after you've designed a digital twin, you can print out parts in a layer by layer structure. So you have one layer after the other, you add one layer. So this is why the whole technology is called additive technology. And with that technology, you can produce totally differently compared to former technologies. And you can save a lot of weight. And that is really interesting to aviation and aerospace. The shipping industry is also very much interested in additive manufacturing because they have very long supply chains. They are on sea for a couple of weeks or months, and therefore they are looking for an interim solution. You can also find the first movies using additive manufacturing for technical things. In the medical sector, we have a lot of 3D printing solutions already, and you will learn later what that might be. Printing food is another trend which just recently came up in the last 3 to 4 years. And the automotive guys use a lot of additive manufacturing, especially if they want to do rapid prototyping. Yeah? And what the rail industry does, this will be answered later. So I already talked about printing food. Why do those guys print food? Because with this technology, you can use other consistencies. And you can print meat, of course, that is not really meat. It's just an equivalent made from soy or other things. With this structure, with this layer by layer logic, it seems to be like meat, as you can see here on this picture. The latest trends, I just visited Israel, which is one of the think tanks also in additive manufacturing. There you can find already the first printers which do not just use an equivalent of meat, but they use stem cells of real meat. So no animal has to die, and that can already be printed. And as you can see here, we've already tried that out. In the fashion industries, AM is used with totally different designs. And also in the bike industry. And what you can also see here is that the design is differently. So you can put material there where you really need this for reasons of strength. And the other parts you can just let away. Adidas or other running shoe providers discovered additive manufacturing. You can see this here in the soles. The sole is printed, also totally different design. And for me, I think it's gorgeous to wear those, especially on fairs. In Scandinavia, additive manufacturing is used for furniture. And you can also think about doing this for furniture and trains, of course. And even wood can be printed, and you can see that there are totally different designs are possible. You can use this as solutions against noise. Yeah, so this is printed. It's a product of the paper industry, and you can save noise with this logic. I already talked very shortly about the automotive guys. And those automotives use additive manufacturing, as you can see here, for this little spare part in a cabrio to also save material and to make things lighter than before. But of course, in the automotive industries, they are struggling with a lot of problems at the moment. So it's not really a sector where it's fun to work, in my opinion. Now we are coming to the sector where it's a lot of fun to work for. So the rail industry. What is the rail industry using additive manufacturing for? In the rail industry, we need big parts. We need very strong parts. We have to save money with that. And of course, we have to fulfill a very high level of certification. And if you ask me, what are the main technologies we use in the rail industries, those you can see here. Starting with the upper left, that's the FDM technology, which is quite common, and I'm quite sure that all of you have seen that already. So with that technology, you can use pellets or like a plastic cable, and with the hot printer head, that material is heated up and in a layer by layer logic laid down on the build plate. On the upper right, you can see a powder bed logic, and this powder is very thin and it's melted with lasers. And those materials can be polymers or plastic in general, and it can also be metal. And you produce a very strong part with that, but it takes a bit longer and therefore it's not very cheap. On the bottom on the left, you can see a technology which was invented by HP, coming from the 2D printing logic. And there they use plastic and also with a high average of metal in that material. And there, with that technology, you can produce either plastic parts or metal parts. And since we are in the rail sector, we need huge, big metal parts. The powder bed logic would be too expensive, and therefore another technology was invented, and that is called wire arc additive manufacturing, where you have metal cable, and that is melted also by lasers, by an electron beam, sorry. And what you can produce with those gorgeous technologies are spare parts. And what you can see here is a little spare part belonging to the climate system of a train. And sometimes you can't get your hands on those parts anymore in the obsolescence logic. So meanwhile, we print this at Deutsche Bahn. And therefore, we need this FDM, the first presented technology, fused filament deposition. And with that technology, you can even produce parts with a very high level of flame retardancy. Last year at Deutsche Bahn, we also discovered additive manufacturing for tooling. It's a bit funny because usually other companies start with tooling because those are low-hanging fruits and much easier if you take certification into account. But we discovered this last year, and what you can do are also quite big parts. And if you have to bring your trains in a big overhaul every 6 years approximately, then you also have to color them again. And therefore, you have to put tape on these lights, and that takes a long time, and you produce also a lot of waste afterwards. So what we've done is we've printed something which you can just put on these lights, spray around, take it off again, and use it at the other lights. So quite easy and quite cheap. In the rail sector, we are also dealing with a lot of customer aspects, of course. Therefore, we've printed braille signs for handicapped and blind people. And with this additive manufacturing logic, which you can find now in half of the train stations in Germany already, we save half of the costs, because there you can produce differently. Before it was done in milling technology, so it's much cheaper. We already also produce safety relevant parts. So what you can see here is a secondary roll stop, which prevents a high-speed train from getting too much into the curves. And of course, that's definitely not only a mobility critical part, it is also safety relevant part. And we printed that nearly 2 years ago. And in wire arc additive manufacturing, that is the logic where you can print big metal parts that has a weight of more than 25 kilograms. And it goes now with the high-speed trains for more than 2 years. But if you print safety relevant parts, of course, you have to take a closer look at the quality. And therefore, we put that on a test stand and simulated another 30 years of operation, although we just need another 8 to 10. And we are absolutely sure that that part stands our high quality levels. At Deutsche Bahn, we've printed more than 80,000 parts in the last years, which means more than 500 different use cases. And we've saved a lot of money with that. Meanwhile, more than 10 million euros. But it's not just Deutsche Bahn using additive manufacturing. It's also the Swedish colleagues. That is an Excel box cover, also printed in this metal technology. And that Excel box cover also has to suffer from big dynamic powers, and it also works. Yeah. The Dutch colleagues use it, for instance, for the housing of tablets. That's also a very common use case in rail in general. We also have that at Deutsche Bahn. And that is part printed by Wabtec. Wabtec is also one of the suppliers which uses additive manufacturing in a wide range of different use cases. Now also working together with SKF and also Alstom and other rail operators like SNCF. So they are very experienced in that too. What do you use additive manufacturing for in the railway sector? That is for clearing obsolescence problems. You can integrate functions. You can save manufacturing costs, and you can, and that is one of the big advantages, use it for very small lot sizes. So you do not have any minimum order quantities anymore. And you can ensure your part availability and do also really interesting jigs and fixtures and auxiliaries, which you can see here in the middle. And we also use it for lean projects like shadow board holders, which you can see here. The rail industry in general, and I can say so because we're in a very close context with 6 other European railway companies, so we cover the big majority of the European rail market. Everyone is looking for different technologies and especially materials, so they do scouting in that. Everyone is also thinking about in-house production, but everyone also says that they will also stick to printing service bureaus because you cannot cover the whole range of potential parts in-house. You need internal specialists, so you also need to train those colleagues and give them information at hand, what they can do and also what they can't do. Of course, you always need digitalized parts. And that is also one of the big challenges in the rail industry, especially as an operator, because usually you do not have the sufficient drawings, and therefore you have to digitize your parts before. This is why most of the European railway companies also do like scanning days where they go into their maintenance sites and scan a lot of parts, so they have the digitized designs on their digital warehouse afterwards. And that means we can also overcome problems in the digital supply chain. So we can produce small batch sizes for that and establish also a stronger presence. You might ask, why are you sure that this is really working? Because we initiated standards. And we did this in cooperation with some other companies and certification bodies. And we established an audit system which a printing service bureau has to undergo if they want to print spare parts for rail. We all learned that we have to suffer a lot of crises, different types of like environmental problems, like viruses, closed harbors, and meanwhile also wars. And therefore, we all have to think about how we can cover the supply chain, even if that might be interrupted by different occasions. And we also have to think about sustainability. And additive manufacturing is the most sustainable technology. Why is that so? Because you can produce lighter parts. That is, as I already mentioned, crucial to the rail, and especially in the aviation and aerospace industry. You can print on demand. So you do not have to put things on a warehouse anymore. You can print them when you need them. You can produce much more locally. Yeah, so you don't have to transport parts all over the world. You can extend your use. So there's no natural end of a life cycle anymore because you can reproduce parts. And you can even do material marking and use recycled materials. That has to improve even more in the AM industry, but this is already on the way. We've done an analysis with this optimized designs I've already spoken about. So what you can see here, it's a cargo hinge for one of our cargo trains, and we've optimized that. And afterwards, we compared those different technologies like casting, milling, and printing. And what you can see then is that you can save a lot of weight, which also means you can save a lot of production waste, and you can save a lot of material. And that is also crucial at the moment, because you all know that we can't get those materials anymore in the numbers like in the past, because many material suppliers are in China, are in Russia, and it's a no-brainer that we have to think this newly. You can save energy, and you can also save CO2 emissions with additive manufacturing. It always depends on the specific part, of course, but what you can see here, those are analyzed numbers and dates and figures. And so we know that that is possible. So this is why Deutsche Bahn considers additive manufacturing as being a green technology. Yeah, and what was also decided is that our DB Schenker daughter started with additive manufacturing in the logic that you can empty your physical warehouses by a print-on-demand logic. We know now that we can already today could print 10% of our parts, which for Deutsche Bahn in the rolling stock area means more than 10,000 different use cases. And that is our strategy. We want to print them until 2030. Of course, there we also have to put some hurdles out of the way, but I'm absolutely sure that we are going to make that. We know already today that 30% of our slowly moving parts can be printed. And that is exactly what we are doing now at the moment. We're considering how to print them and to save a lot of money, because if you put something in the warehouse, of course, that is capital you cannot use for anything else anymore. We are busy with scouting different materials like flame-retardant polymers. You already have solutions for that, but there should be more. Elastomers for different use cases. Sand molds is really attractive, because with printing sand molds, you are still in the traditional technology, but you're much faster in the production process. Printing copper is really interesting, aluminium, of course, and even concrete. What you can see here is one of our station benches. Those are the technologies for printing elastomers and also concrete. And even in the concrete sector, there are already, again, different technologies on the way. Printing elastomers might be interesting for seals, for bellows, for large rubber components, for elastic holders, and whatever you can think of. And if you want to put them on a warehouse, you cannot do this endlessly, because you have to throw them away after 6 to 7 years. Printed benches, you've already seen one, is one of our latest projects. Yeah, and you can also here again do different designs. What are the next big things ahead? Liquid metal printing, also interesting, because it's a very cheap and inexpensive technology for metal parts like housings. Micro printing, so everyone's looking for electronic spare parts, and there's a promising Israeli company called Nanodimension who's busy with that. But that will take, unfortunately, another 3 to 4 years. And macro printing, so printing huge, big parts. And that is also a new technology. What you can see here, it's a mixture of FDM printing, because you have 4 plastic cables, but not round ones, but their shape is like with tough surfaces, and that is melted with a laser. So with that technology, you can produce very big things, and they are very tough and strong. You can print in containers, locally independent. This is, by the way, also what's interesting for everyone who's doing maintenance, also in the defense sector. And you might be a bit confused by now about all those different technologies. And if you would like to learn more about and share your knowledge and get some knowledge, this is why we founded MGA. And within MGA, you find a lot of users from different sectors. You will find printing service bureaus. You don't have to buy a printer right away. You can also try things out. A lot of universities and machining producers, as well as consultancies and bodies you would need, and of course software companies, as well as material providers. So within MGA, you will find approximately 150 companies throughout the whole additive manufacturing. We work in working groups in 2 different fields, which is mobility. And there you can also find a working group, which is called approval in rail, of course, that deals with rail tasks, as well as rail liability, where all those rail operating companies come together. You will find materials working groups and working groups from different sectors like automotive, aerospace, and so on. And 4 years ago, we founded a medical sector, which has nothing to do with the rail sector, but still is really interesting. And they are dealing with the same challenges as the rail colleagues do. And so it's also interesting to get into an exchange. If you would like to get more different use cases and you would like to get informed which materials are printable, that's weboostam.com with a lot of information. And you can also visit us in Berlin. Yeah, warm welcome already, where we have a huge exhibition of printed parts from different sectors. And this is where you can find us in the south of Berlin, with our industrial additive manufacturing hub. And we're doing a lot of events like a tech journey beginning of February to the United States. We are also at different formats like Hanover Fair, or we're doing a cooperation for a 3D printing students competition, and a format which is called LightCon for lightweight solutions. And we have a huge conference in Berlin about additive manufacturing with approximately 2,000 participants. That's the Additive Manufacturing Forum taking place in July. And of course, our own annual meeting within the network in September. You will find us on the Railway Forum, which takes place in Berlin in September too. And I've already mentioned our annual meeting. This is where it took place last year. And you're more than welcome to join our great network. And thank you very much for your attention.
Yeah, Stephanie, thank you very much for the very impressive presentation. I'm waiting to receive 3 printed food in the ICE board restaurant, and maybe that is the future, or a part of the future. And you are also mentioned the different occasions where you are present for sure. And as I mentioned, ERCI has also is planning to have several possibilities at trade fair shows. For instance, at CIFA in Lille, in Krakow, in Gdansk, and also I have in mind that there is a railway interchange fair in Indianapolis in the beginning of October, and for sure you are all so welcome to join us there. So I have some questions on the desk, and the first one is about your network. And you mentioned huge companies which are members of your network. And how many women are in your network? Is there existing women in 3D printing initiative?
Yeah, that's really interesting because I'm now in the railway sector this year for 25 years, and I was always one of the few women in our technical department at Deutsche Bahn. And I always thought that the average number of women in rail is quite low. In AM, it's just half of that. Yeah, so this is why we initiated also a conference, Women in Additive Manufacturing, and I'm also going to take part in a really interesting virtual conference next week that is organized by Women in 3D Printing. It's called Type Conference. And apart from that, you will find a lot of really interesting and high-level women speaking about 3D printing. It is really interesting to join. It's for free, and I put the website now in our chat so that you can find that.
Yeah, I will resort the questions a bit. There was a very further interesting question by a woman, and it is also regarding your network. And the question is how to engage with the different working groups.
Yeah, so it's an association. It's a German Verein, and you can become a member. You can apply for a membership, and then you can join all the working groups. So also the medical ones. It's like one price, two different networks, and it's very inspiring also to listen to the medical use cases. And if you need some more information, I also put the website in the chat, and there you can find all the information you need to become a member. You can also contact me, and we can discuss this a bit further in detail in the talk.
Yeah, that's an additional question by Susan about your V card, and be sure that all the presentations shown today are available afterwards, and I will send all of you an email with all that presentations, and also with the recording of that webinar, so no information is lost. Now, the more technical questions, which is the difference of price amongst a steel part or other material and an additive manufacturing one?
Yeah, that's not easy to answer because usually the price is higher, but it depends what you compare. If you compare the production costs for one part, if you have to reproduce a part and compare it with milling, additive manufacturing is much cheaper because you don't have minimum order quantities. If you compare it with other technologies, you don't have to build tools before. But usually, if you compare just the costs, it's like up to 10 times the price of a metal part. But as I said, you don't have any minimum order quantities, and that's the big advantage. So if you have large numbers of parts you would need, stick to the former technologies, that's cheaper. If you have small amounts of parts, then use additive manufacturing. Or if you want to do totally new designs, then additive manufacturing makes a lot of sense. I just want to give you also one more example. At Deutsche Bahn, we are dealing a lot of obsolescence at the moment, but now we are going to bring it in front of the procurement of trains. So we are at the moment designing in cooperation with industry the new trains, which will be the follow-up train of the ICE 4 generation. And there we want to bring in additive manufacturing right away. So we can also think about new designs. We can think about printing on demand logics. This is what's going on at the moment. And those new trains will be on tracks in a couple of years.
Yeah, the next question, do you have also experience with graphene printing, especially for railway applications?
What is graphene? Graphene printing.
Can
Can anyone help me? Can you put on your mic
this
and
It's
a 2D material used, it is again extracted from coal.
yeah,
okay.
graphite.
Yeah, I think it's
Yes.
more like carbon.
Yes,
Carbon materials.
exactly.
Yeah. Carbon is also used in the additive manufacturing sector, where you bring in carbon into plastic materials, which makes it a lot stronger. We use that for tooling. We do not use that in trains at the moment. Yeah, so this is one of the maybe new fields, but usually that is no matter what technology, it's a very very expensive material as far as I know. And so maybe that's one of the future fields, but not for now.
Yeah, one of our participants sent an Wikipedia link into the chat on the graphene material, and there is a last question. What are your experience with certification of safety relevant parts? How long does it take? Is it complicated or not so? And I think that is a big topic anytime. If you produce safety relevant parts, for sure you have to authorize them.
Of course. So at the moment, if we want to replace existing spare parts, we have to prove that form, fit, and function is nearly the same. So as I showed it with our a secondary roll stop as well as an Xbox cover, we put them on test stands and we do a lot of material improvements. And that is, it takes time. It depends how fast the colleagues are and how urgent the use case is. So if we have to have a standstill of trains, they are usually a bit faster than in other cases. But you're absolutely right. It takes a lot of time. It's time consuming. It depends how safety relevant and critical the part is. It's between a couple of weeks until a lot of months. But those railway spare parts we're talking about here, we have lead times of more than 1 up to 3 years. Yeah. So if you want to produce or get those spare parts on the markets, it also takes a lot of time. And there, of course, you have time to fulfill the certification. What we are doing in the network is we want to bring this on a new level. And therefore, we have this approval and rail working group in cooperation with suppliers like Knorr, Siemens, and other certification bodies like the TUV, with light rail suppliers and operators, where we want to establish a logic that you can do this with and prove the strength of parts by simulation. So you don't have any destroy testing in the future anymore. And this is what's going on in the network. And this is exactly the logic of MGA. Join forces, do this in cooperation, then it's getting faster and cheaper for everyone.
Very interesting and good to know, as at least one of our participants is part of the Italian certification body, and maybe there could be established some good context after our webinar. So thank you very much so far. I have seen no further questions in the chat so far, but you are still invited to raise your question on the next presentation as well as on Stephanie's presentation. And there is one question from our next presenter, isn't it?
Yes. Well, I just wanted to add something to the response to what is the cost of additive manufacturing parts compared to traditional manufactured parts. I kind of have two different answers to that as well, because it doesn't always just depend on the final cost of the part, because there's other costs associated with them. So one of them is basically in the space industry, they're very time sensitive. So it's what they call touch time. So from the moment that they finish a design until the moment that they receive the part back in their hands is their touch time. And they really want to minimize that as much as possible, because during that time, there's basically kind of a dead time that they're not able to work. So the faster they're able to get parts back into their hands, the faster they're able to iterate their designs, test it, validate it, and get a product either launched into space or on the market. And that comes at an opportunity cost, and it's a little bit difficult to calculate that sometimes because it's very specific to each company what that opportunity cost is. And the other cost is, something that I think, Deutsche Bahn and Mobility Goes Additive knows very well. It's the total cost of ownership. We were talking about digital inventories, and when we did a project once, we started working with a medical company, and we realized that their way of traditionally manufacturing these spinal cages for implants was either through injection molding or through CNC milling. But they had a lot of different designs, slight variations of every design. But if they wanted to have the solution be available to a particular patient, readily available, they would need to manufacture all of them and keep them in inventory. And there's a very large associated cost with that, because every part needs to be milled or machined, and it requires setup costs. And then you have to store all this in your inventory. And when you're talking about, say, high-performance polymers or medical grade, implantable grade materials, this becomes very expensive. So there's a very high associated cost of ownership for having a solution in your inventory. So once you get rid of your inventory and you have a digital inventory and you just have the raw material and you can print it on demand, this greatly reduces your cost. So I think that's something that I would like to add to Stephanie's response there in terms of the cost of 3D printing compared to traditional manufacturing.
Yeah, thank you. And I just shared my screen again in order to announce your presentation, Adam, on 3D printing plastic spare parts with injection molded strength and density. And you are the managing director of the Orion Additive Manufacturing company here in Berlin. And the floor is yours.
Thank you very much. So, I'm really, really grateful to have the opportunity to present here today. And some of you may not know us, but we're also a part of the Mobility Goes Additive and Medical Goes Additive network. So Stephanie and I know each other well, and we're really happy to be here co-presenting together. So I'll start my presentation.
Yeah, perfect.
So for those of you who are hearing about us from the first time, we are Orion Additive Manufacturing, and what we focus on is development of additive manufacturing solutions for high-performance polymers. And what we're able to do is we're able to print these polymers with basically injection molded strength. So when we speak about high-performance polymers, these are usually thermoplastics that are kind of at the top of the pyramid, that are used in these really advanced applications, whether they're in space or they're for medical implants, but they have really high strength, so some of the strongest plastics in the world. And they could also be used in places where there's a need for high temperature resistance or high chemical resistance. So some of these polymers are listed here below, but one of the more popular ones is PEEK, or the family of PEEK, polyether ketone, which comes with other polymers like PEEK or PEC as well. So, the challenge in printing with these polymers is basically that, as Stephanie mentioned earlier, we're always printing them one layer at a time, so stacking one layer over another. And in a lot of processes in this kind of FDM layered manufacturing process, the layers don't bond really well together. So it makes it a little bit weaker. And this weakness in the interlayer bonding basically causes it to fail prematurely or to delaminate, or it may not be as strong as what you would expect in, say, traditional manufacturing, such as CNC machining or an injection molding. So this can have an impact on the final application, because it depends if it's a structural part or if it needs to be, used for its full strength or for its full capabilities. So what we've done is we basically created a process, a proprietary process that we developed on our own for the last 4 years, which uses thermal radiation to basically apply energy towards the material during the printing process. And when we do this, we're able to fuse all the parts, all the layers together, and we're able to get a nice consolidated structure that's homogeneous and fully dense on the inside. So you can see on the bottom right here that in the bottom section of this image, you can see how the internal structure looks when we use thermal radiation heating, and what happens when we turn it off. And this is when you start to see these voids show up again, and it lowers the density and also lowers the bonding of these layers. So we've tested this technology. What you see here is actually a vertically printed tensile test bar. And as it's being pulled, you can actually see it beginning to stretch. And it's a characteristic that we call necking. So you can kind of see it starts to slim out in the middle of the section here before it breaks. This is what you would expect from an injection molding part. But this is actually a 3D printed part. And not only is this a 3D printed part, but this is also oriented in the weakest direction that you would normally expect a 3D printed part to behave. And the final outcome was actually that we achieved a tensile strength that is actually higher than injection molding, which was actually beyond our expectations. So when we first started this project, we thought we were going to get very close to injection molding, as close as possible. That was our goal. But what we actually ended up achieving is getting stronger than injection molding. So the next slide here actually shows all of the data. So PEEK is one of the materials that we work with quite a lot, and there's 3 main PEEK suppliers in the world. Solvay is based out of Belgium, Evonik is based out of Germany, and Victrex is based out of the UK. So we have their materials here. We actually worked closely together with all the material suppliers to test the materials. We print them, we send them back the samples, and they test them in their own labs to make sure that it's validated using their own testing processes, and there's no biases there. So all across the board, in the flat orientation, which is kind of fairly standard, it's already 10% higher than injection molding. This is kind of the on edge orientation. It's still higher. And then on the vertical direction, this is basically pulling all the layers apart. It's the worst, weakest orientation. And even in that orientation, we're higher than injection molding. So you can see this line here represents the injection molded strength. And all these bars here, these 3 bars represent the different orientations, including Z, which is the weakest direction. So this is, on the right here, you see kind of a benchmark with our competitors and how the strength differentiates using the Orion Additive Manufacturing process. So what this really means for us is that you no longer have to make compromises when it comes to additive manufacturing, especially with high-performance polymers. You don't have to think about what is the weakest link, because normally you would take your weakest orientation and you would say that is the maximum strength you can get out of this part, right? And then when it comes to certifying these parts or actually rolling them out into an end-use application, you have to take that into consideration. So it's a highly compromised part in that sense. But in our case, with our process at Orion Additive Manufacturing, you don't have any compromises. So you can take a part that you used in an injection molding process or CNC machining process, and you can 3D print it without having any compromises at all. So we've focused on a lot of different applications, but one of the application areas that we focus a lot on are in space applications, and we've also worked with the European Space Agency to validate our process with a special material that they came up with. So this is a material that is based on PEEK, so polyether ether ketone. It's the strongest plastic in the world. And they added carbon nanotubes and graphene platelets to this material to create a conductive material for space applications specifically. And they've been going through a lot of validation of this material, but they wanted to see what we could do with our process to improve the mechanical properties of this material. So the as printed was actually with one of our competitors' technologies, And as printed, Orion is using our technology, and we were able to increase the strength, the flexural strength by 33%, and the flexural modulus, or the stiffness of this material, by up to 87% using our technology. So this was really great validation, for us and also for ESA to show, what can be capable using this material with our process, and kind of opens the doors for more opportunities into applications in space. A little bit more on that later. So the other part of it is also our process is able to achieve a really high density. So when it comes to, whether it's for implant applications or railway applications or space applications, this density has a major impact on the structural integrity of the part. In some cases, especially in space, for example, if you have internal porosities or voids, this can actually be quite problematic because of off-gassing. So if you have air or a gas trapped inside, once you launch it out into space, if this gas leaks out, it can be very problematic to scientific instruments or sensors, where some of this gas basically comes out of the material and then accumulates onto these instruments. So we're able to prove that we actually have a void content of less than 0.05%, which is basically on par with injection molding and CNC machining, which makes it useful for validating our process in comparison to these other traditional manufacturing methods. So it's strong enough for space. It has injection molded strength, and there's many different applications that you can use it for. As Stephanie also mentioned, one of the main benefits of 3D printing is mass reduction. And in some cases, some of these materials that you see here are actually typically used to replace metal parts because they perform as well as, if not better, than some metal parts such as aluminum. So PEEK, for example, it's very chemical resistant. It has actually a really similar strength-to-weight ratio as aluminum, but it's half the density, so that means it's half the mass. So you can actually use it to replace metals in some cases where you're concerned about corrosion. So, for example, fuel line brackets in the aviation industry, aerospace industry, are sometimes replaced with PEEK because they don't suffer from corrosion, such as aluminum brackets do. Right? And there's other clear benefits as well, such as you can take advantage of the ability to add more complexity, reduce the number of parts, integrate a lot of features into a single printed part, and take advantage of the faster production time as well. So I want to show you a couple of space applications that we've worked on, just to maybe get some ideas also in terms of what could be possible in the rail industry. So we've worked with a couple of different materials. The one that you see here on the top left is printed in ultem. This is high temperature material as well as chemical resistant. It's already approved. It has an FAR certification for approval in the aerospace industry. So it makes it an easy drop-in material for railway because of its low flammability and properties for flame, smoke, and toxicity. The one in the middle here is a PEEK CubeSat. So this is primarily used because of its high strength properties. And the one on the right here is another part for a CubeSat. It's actually a battery pack that goes inside of a CubeSat, but this is made with carbon fiber filled PEEK. So what was interesting about this application is that we started with a CubeSat frame, and the end user didn't really have a lot of experience, and they wanted to understand more about 3D printing and see if we can actually achieve some of the specifications that were required. And we proved that we were able to meet the requirements for this particular application, and it got them really excited. So they started getting more and more ideas once we started working together, and started thinking, okay, well, these internal components inside, can we also print these? And, this is a frame for an antenna. This is the frame for a smaller battery pack. And we said, yes, of course. We can print those, but let's work on a new project. So we started this battery pack project because they had this traditional aluminum manufactured design, and they were having a lot of problems. The battery cells needed to be connected together through these wires, and these wires had to pass through the frame, and they were always getting pinched and causing short circuits inside of the battery pack. So they're having a lot of issues, and they were trying to iterate their design and move faster. And the only thing is that it usually took about 5 to 6 weeks for their parts to be manufactured by CNC machining. So if they found an error in their design, if they couldn't fix it themselves, they would have to go back to the drawing board, redesign it, and wait 6 weeks for a solution. So we came up with a new design, improved design, that used non-conductive materials. So it's an insulating material. And we were able to iterate on this design very quickly. So within a matter of days, we had a new design, and then we were able to print it within a day or two and deliver this new solution to them. So that was one of the things that I think really highlights the benefits of this technology. One of the other materials that we work with is a material by a company called IGUS. So this is a dry bearing material, and this is where it becomes really interesting because it's a high temperature material as well. But it can be used in cases where you have bushings or dry bearings, or even in this case, we've shown a lead screw nut. So it can be actually used for automation components as well. And the bottom right here, this is actually a demo part that we printed at a trade fair. We broke the part just to show that when printing with Ultim, it's not just PEEK, because we've done a lot of validation with PEEK, but in other materials we can also print them with very high density. So we actually just found out about this recently because the publication only came out a few days ago, but we are on our way to the moon. So this rover was launched in December, and the European Space Agency just made their press release a couple of days ago. But we have some parts that we printed for the European Space Agency with this special material that we showed you earlier. And it's sitting on the wheels of this rover. And this will be the very first 3D printed parts on the moon, and also the very first European technology to make contact with the surface of the moon. So it was a real privilege and honor to be able to work with the European Space Agency on this, but this really kind of proved, it proved to them our technology was able to basically perform as good as injection molding. And this is why they chose our technology to be able to produce these parts to go to the moon, because they knew that there weren't going to be any compromises in the material properties. You can get all of the material properties out of the printing process. So we aim for the moon, but I think that kind of shows if it's good enough to go out into space and be on the moon, it's also good enough to be on a train in the railway industry or in other applications as well. So getting back to down to earth. What we also wanted to show is some of the parts that were printed by our partners, 3D4 makers, using this Ultim material. So actually, this is polyephemeride, PEI. It's actually not exactly the same as Ultim. It's the same as Ultim 1010, which is just pure PEI. So again, this is a high temperature material, low flammability. But this was developed by Lehman and Voss. So it's a material called Luvacrom 3F PEI. And they added some special additives into this material that actually makes it a very, very superior material for flame, smoke, and toxicity and fire resistance. So it actually achieves one of the highest classifications for flame, smoke, and toxicity, which is R1. So it's definitely compliant with the EN 45545 standard norm for flame, smoke, and toxicity. And so we think, if we're looking for something that's able to replace injection molded parts or CNC milled parts, and we want to build spare parts for the railway industry that are also compliant in terms of flame, smoke, and toxicity, I think this would be a really interesting solution for those that are looking for something that is able to comply with that, but also maintains all of the mechanical properties that you want out of the material as well, right? So that's something that we wanted to highlight. Kind of looking at our company, we are a fairly young startup. We started in 2018, and we developed this technology which has a lot of potential. and we're kind of looking at where we want to go next. And in terms of lightweighting, especially for the aerospace industry, composites is kind of where you want to go. So we've been examining this, and last year we took the opportunity to evaluate our thermal radiation heating process to see how much we can improve the process of printing with composites. So on the market today, there's a few printers on the market, such as Anisoprint or 9T Labs or Markforged is probably one of the better known ones. But these printing processes, they're not really consolidating really well all of the fiber reinforcement content, and the fibers can still kind of delaminate from each other. And this has a bit of compromises in terms of the mechanical properties, so you can't get the most out of it. But also some of these materials, they're not suitable for particular applications, such as in space, because the Markforged material, for example, is infused or impregnated with polyamide, which is not usable in a space environment. So we wanted to see if we took peak and continuous carbon fiber and applied our thermal radiation process, could we also improve the mechanical properties? And so our studies started looking at, what would happen if we didn't use it and what would happen if we did use it. So you can see a clear difference here in the tensile strength. When we didn't use thermal radiation heating, we got 850 megapascals. So really similar to Markforged, but when we did use thermal radiation heating, we increased it by, almost over 400 megapascals, so 1,260 megapascals tensile strength. And another significant improvement is also the flexible modulus, which is the stiffness and bending. So compared to Markforged, we're more than double the stiffness in this material just by using, thermal radiation heating in our process. So I think this really kind of changes, how we think about additive manufacturing, because we typically think, with printing parts, there are some compromises, and also when it comes to composites, it may not ever be as good as traditional composite manufacturing. But I think looking at how we can apply our process to improve this, I think we can now start looking at creating solutions where there are no compromises. But of course, this is still something that we have in development, and we hope to share more news about our developments in composite additive manufacturing in the near future. One of the things that were brought up were also in terms of certification. So, we also learned from, actually in the last MGA annual meeting, we saw a couple of presentations about, how parts are made and certified for the railway industry. And when it comes to structural parts, it takes a very long time because you have to make 5 parts and destroy 4 of them. So there's a lot of destructive testing. There's a lot of shock. Just like in the space industry as well, they do shock and vibration testing. So I think what we've managed to do in our process is we've been able to show that we can consistently achieve, high strength that is as good as, if not higher than, injection molding. And I think if we can continue to prove that we can do that, it'll be easier for us to certify parts directly out of the printer, so that it's, we know that, our process is stable and it's able to consistently achieve these mechanical properties. But the other part of it is also just understanding, did our process introduce any sort of errors or gaps or voids into the final product, and are the dimensions within the correct tolerances that we're expecting? So this is something that we're also rolling into our developments, is how do we monitor this process in situ so that we can either correct it on the fly with in situ process monitoring, or at least have a warning that we did not meet our target dimensions, right? Because I think at the end of the day, all of these processes with additive manufacturing, they're really great, and they show a lot of promise. But at the end of the day, I think the ultimate goal is to be able to take a part directly out of your 3D printer and have it qualified or certified, and know that it's going to behave as good as an injection molded part, or a part that was designed by an engineer, right? And what's interesting is, I think with additive manufacturing we have the ability to do that, but it's all about kind of taking pieces from other technologies and adapting it to ours, and making sure that we kind of make the right integrations of the advanced technologies that we have available to us today to be able to create such a solution. So this is kind of where we see additive manufacturing going, to be able to do quality control directly inside of the printing process so that we get finished parts coming right out of our printer. So I didn't touch so much on the implants because I realized, this is, presentation focused a little bit more on the industrial applications and railway industry, but just thought I'd take a short moment to share with you some of the things that are possible in terms of the medical industry. We work with this PEEK material, which is also a biocompatible material, and it's typically used to replace titanium. So it's just, I think, kind of interesting to explain to the audience that this material is very strong, and it is used to replace metals. And I also speak a lot about PEEK, but we also print with other materials. So PPSU is another material. It's used quite a lot in the medical industry, but it also has other industrial applications as well. But it is similar to PEEK. It's a very high strength material, and it can be used in places where maybe PEEK isn't required, and you want a lower cost solution. But PPSU, it's similar to polycarbonate because it's an amorphous material, but it has a very high impact strength. So, when we first started looking at medical applications, I think around 5 years ago, people told us that, we don't think we're ready yet. They didn't really see 3D printing integrated into hospitals at the point of care, is what we call it. And today, 5 years later, we're starting to see people actually begin integrating it into hospitals and saying, this is now a reality. And I think 5 years from now, I think we're going to see a lot more 3D printing happening in hospitals, because it's one of these solutions that I think just makes a lot of sense. Where when it comes to implants, we're not usually mass producing implants. So something like a cranium implant, it's something that you will make once or twice, but there's a really high value in that. So I think when it comes to looking at applications, I think we have to find ways that we're addressing applications where the technology is the most suitable for a particular application, because you don't want to take an application that's traditionally used or traditionally manufactured using injection molding if it just doesn't make sense, right? So I think looking at particular applications such as patient-specific implants, where there's a high amount of customization required, it makes more sense to use additive manufacturing in this process. So some of the applications that I just mentioned are shown here. The cranium implants are probably the most beneficial case for additive manufacturing. They really highlight what the benefits of additive manufacturing can add in terms of value there. But there are also spinal cages. I mentioned earlier that when we worked with our first customer in spinal cages, we thought they were just 3 different sizes: small, medium, large, and that is what was traditionally done before. But it wasn't actually the best solution for the customer. It was just what the industry offered because it was the most cost-effective solution. But the best solution for the customer is actually a patient-matched device, so it fits to the patient's needs, right? And I think this is really how we're starting to see additive manufacturing change solutions that are happening in the industry. So we've also done some other solutions here. So on the top left, you see these dental implants. So it's to kind of also show you that we can manufacture very small parts as well using this technology. And the one in the middle is actually a heart plug. So I wanted to show this one because it actually shows how we can combine technologies to get the most out of each technology. So this particular case here, this heart plug, was actually manufactured using both additive manufacturing and subtractive manufacturing, or CNC machining. So the reason why we did this is because this was a design that required a couple of different sealing surfaces. So there's an O-ring groove here where an O-ring seal needs to fit in, and there's a face seal here where a small silicone ring fits over top of. And these sealing surfaces are requiring a surface finish that's very yeah, it's a very fine surface finish. That's very difficult to achieve with traditional additive manufacturing. So what we did in this case is that we made a 3D print that was a near net shape, and then we printed some features that could only be produced through 3D printing, and then for the sealing surfaces we just finished them with CNC machining. And it was interesting because when we gave the part to the machine shop, they looked at some of the features here that you can see. These are the locking features for the heart plug, and they said we can't manufacture these features here. And we said, don't worry about that. These are, just leave them 3D printed. You don't have to touch them. Just finish off the sealing surfaces. And I think this really highlighted how you can get the best of both worlds. So not to say that additive manufacturing is the only solution and you should only use additive manufacturing to achieve everything, but we use, a mixture of both solutions to be able to get the best out of each. Okay. And yeah, this other material here that you see on the bottom, this is also PPSU. So, you can use it for scientific instruments. So you have to look at, the cost of the material as well in terms of, whether it's the most suitable for your application, because PEEK is definitely the strongest plastic in the world, I would say, but it's also a very expensive material. So sometimes it doesn't make sense to use PEEK. So I think we always have to look at, the process and the material and see, what is the best solution together to address a particular application. So that pretty much concludes my presentation. So, you have my contact information at the bottom here. This is our general email address, but yeah, you can reach me there as well, or find me on LinkedIn. And I guess I'll pass it back over to Lutz to see if anyone has any questions.
Yeah, thank you very much, and well explained. So I have no questions in the chat for the moment. Well, yeah, now I have one, but I have two questions from my own. I'm starting with this. What further potential use cases do you see for your technology in general, and with a special focus on the railway sector in the future?
Yeah. So, as Stephanie also showed, I think in terms of the railway industry, the parts are normally quite large. So we started our process to validate it with a smaller footprint, just to make sure that we can achieve the type of properties that we can achieve. But I think when it comes to addressing, the railway industry, we definitely need much larger parts. So I think we're still kind of in this phase of exploring where our technology could be useful. But it definitely seems that, more on structural parts, structural plastic parts that are critical, in terms of the railway industry. And I think this is something that we need to kind of discover a little bit more on our own. More in general, I think the more clear the application is, the more chances it will be successful, where there's a clear advantage. And, I ended with medical because, I have to say it's something that we started with, but we kind of moved away from. But then it just kind of keeps coming back to us. Like everyone keeps coming to us and saying, can you print medical implants? Can you print it for this particular application in medical? And we just also got a request yesterday from somebody in Ukraine who's been 3D printing implants for wounded soldiers. So there's definitely a lot of soldiers that are being wounded either on the battlefield or because of stepping on landmines, and they need an implant. But we're seeing also the reason why they need access to this technology is because they can't access one of the 3D printers that they had because it's in an occupied zone at the moment. So we see additive manufacturing having an impact in many different industries. I see medical as being one of the strongest value propositions for our technology. It's a really clear application, and we also see this idea of distributed manufacturing, to basically bring the manufacturing closer to where it's needed. So I kind of see this as the future of additive manufacturing.
Yeah, as the time span is seems to be very critical in the medical sector. What is the duration from order to application of a 3D printed part for medical applications? What?
Yeah. Well, I mean, this is also where I think we have a really high value proposition because you know, when it comes to medical implants, there is a certain amount of time that you have to wait when somebody suffers from a trauma. But after that, they need to get their implant as quickly as possible. And you know, I think here in Europe and maybe in North America, you know, where we have a lot faster access to some of these solutions. But you know, I spent some time living in South America, and in Colombia, for instance, it's very difficult to get implants imported into the country. So it can take months, and of course, there's also extremely high costs. So some of these solutions are only available through you know, multinational medical companies, like big medical companies, and they're costly. You have to pay very high import taxes, and they take a very long time to be able to pass through customs to be able to get that solution. So in the meantime, you know, a patient who has just suffered a trauma is waiting for this implant with, you know, it could be part of their cranium exposed, and that is not an ideal solution. So, you know, I think when it comes to our solution, you know, as soon as the patient is ready to receive the implant, you know, it's just a matter of days. You know, we print an implant, we work with a surgeon to test it on a biomodel to make sure that it fits. And once everything is ready, then we print the final implant and, you know, sterilize it, and it goes into the body. So it's just a question of days.
Yes, one last question. Are there any performance or comparative data about medical fatigue stress available?
Medical fatigue stress, no. So we've done
Of mechanical fatigue stress.
Oh, sorry. Yeah. Mechanical fatigue stress. So there's a lot of different tests that are required for every different application. So what we've done is we've started collecting some of this data that is more general. So we've done the tensile strength data and the flexural strength data, and this is the data that you would typically see in the data sheets. But every application has a different test that is normally classified under a norm or a standard. So, for example, with cranium implants, there's an impact test, and with spinal cages, there's a slip out test, for example. So they kind of try to compress the spinal cage between two surfaces and then try to push it out to see how easily it pushes out. So there's you know, in terms of mechanical fatigue, I think it really depends on the application. So it would, you know, these kinds of tests would need to be addressed depending on what the application is.
Yeah, thank you very much for all that interesting insight into the molding, injection molded technology. And yeah, I'm coming to asking all of you, what is your impression on this webinar? You are kindly invited to fill in our very short questionnaire in not more than 2 minutes to tell us what was the quality of organization presentation, what future topics you are interested in, and that helps us very much to design the next ERCI webinars. Then a short information on the EN supply chain resilience platform. That is a platform that is already exists for 10 months. And it is designed by the Enterprise Europe Network, and companies has the possibility to indicate their demands or their offers in order to complete supply chains. And for the moment, more than 800 participants from more than 14 countries are in this platform about a quarter of them is from the transport sector. And also it's the same thing then for the Stars and Match events platform. The registration to this platform is free of charge, and you can ask for meetings, for virtual meetings to other participants, and maybe you could find some interesting partners in order to complete your value chains and make them some more resilient. So next slide is the last slide. This is the announcement of the next combined ERCI and STARS webinar. It's on a future topic. It's on hyperfreight, a new concept for freight transport. You already know for sure the Hyperloop. And hyperfreight is that innovative concept will be presented by two Italian guys and will take place on the 1st of February. That means in 2 weeks. The registration is already open, and you can find the registration link also in the chat. And for sure, you can use our questionnaire, short questionnaire, if you have ideas for some more topics for ERCI STARS webinar. In last year, we had in total 14 webinars. That means not strictly every 2 weeks. For sure, we will have a summer break in this year too. But our goal is to provide you some innovative topics, some innovative companies also this year during our ERCI webinars, and be excited on what topics we are presenting to you. For the moment, thank you very much. If one of you hasn't registered for this webinar on a regular basis, I'm afraid I do not have the email address of that person. And if you are interested in receiving the material from this webinar, for sure, don't be shy to write me an email. I put it in the chat. And then see you for the next time, and thank you for your attendance, and see you soon. Bye bye. Oh, there's one. Just a minute. There's one question. Yeah. You can open your micro and raise your question immediately. If it is not the case, thank you very much, and see you soon. Bye bye.
Bye.
Bye bye. Thank you.
Bye. Thank you.